Hello everyone, this is a little video to show people a few of the bits of the construction of the Bellboy device which are easy to show a video rather than describe on text. So what I'm first going to show you how to do is to prepare the case. So this is the case that I've chosen for the particular project. I've actually temporarily screwed the PCB in there, and you'll see why in a second. See the battery compartment is on here. The other half of the case we're just not using for the time being. So the first thing we need to do to prepare the case, we're going to be mounting the LED and the switch in holes in the case made opposite these two contacts. So we need to mark part where in the case the holes are going to go. So the way I do that is just line this up and just make a small pencil mark here and here, so you can see those pencil marks. I'm now just going to get rid of the PCB to get that out of the way. Then to put more strength into the case when you're actually making the holes in the case, I put the top half on. And then I'm just using a reamer here to make the hole in the case, but you can use whatever system you like. The positioning is quite important to the holes. You'll see that this groove between the two halves of the case, you want to be, let's say, 0.5 millimetre below the groove. So about 0.5 millimetre below the groove to get this in the right position for the when you eventually have the LED and the switch in. So this is the hole for the LED. Oops. And this is the hole for the switch. Now the hole for the switch, although I'm only making this a reamer, only makes a 3 millimetre hole. You need a 5 millimetre hole for the switch itself. So I'm just going to use another little device here to make this hole big enough. This is the hole for the switch. Make that big enough for the switch. And you can just test fit it to see when it's big enough. That's never big enough. Almost set. Okay, fine. Once you've finished that, you can clean up the inside of the case. Little bits of swarf there. And that's put that part of the case preparation done. The next thing you want to do is to put the battery terminals into the case. I just glue these in. I think they're meant to fit by way of meant to fit by friction, but I never seem to have them quite tight enough. So I just glue them in. The batteries are wired in series, so this is how you are going to be wiring it. So positive terminal of the battery, negative terminal of the battery, positive, negative terminal, positive, negative terminal. Okay, same for the other side. So this is a negative terminal here. Oops. Oops. Rather annoyingly, this one doesn't appear to want to go in. I think it's because I've got rather a lot of solder on the end here. Just give me a second just to try to make a quick adjustment. Let's see if this goes in now. There we go. Now, to secure these battery terminals in place while the glue's setting, I just actually put batteries in. Make sure everything's in the right position, and then just leave the glue there to set. I just leave it overnight. Okay, the next thing to look at is preparing the printed circuit board. So what I do like to do here, so notice that there's the top side of the printed circuit board is here. This is so you can tell the two sides apart from each other. So what I do like to do is actually glue the little IMU boards that we've got here, the GY521s, and actually glue them to the board to make sure you've got everything absolutely square and in place before you solder them in. It's probably not essential, but it's probably I still think it's a good idea. So I'm just going to do that now. Just the tiniest dab will be absolutely fine. And remember, we've got two of these GY521s, so tiniest dab of glue each time. So put them in, get them in position, make sure that they're nice and square. There's lines on the PCB which will help you get them square. To make sure they're even more square, if you like, you can put these pieces of header in and put the header through, so it's sure that the holes are lined up. So that's one. So clamp those on, make sure they're still square. It's okay. I only leave that to set for the glue overnight or so. But in true Blue Peter fashion, here's one that I've already prepared. You'll see that I've glued in the IMU boards. I've glued in the IMU boards. I've also soldered in the components on this side, just the 4 diodes and the 2 resistors. Nothing very interesting to note about the soldering there, just that the diodes need to be the right way round. The band on the diode matching the band on the board. You notice that I've soldered in these 2 headers here and here where the LED and the switch are going to fit. Note that these headers have been soldered in the wrong way round, with the plastic on the bottom side of the board. That's because there's not enough room to have the plastic on the top side of the board, which is where they'd normally be. So the plastic here is on the bottom side of the board. So I don't know if you can see that there. So, and I've also put this sticky pad on, which acts as a bit of support for the Raspberry Pi when when eventually putting that on as well. So I'm just going to show you now how I actually solder in these IMU boards. they need soldering in from both sides. So I've already done this one. I've not done this one. I've left a couple free on this one. I haven't actually soldered a couple of connections on this one yet, just so I can show you what needs to be done. This green wire you see here, this is a prototype printed circuit board. You won't need to do this green wire for the one that you have when I have the finalised circuit board, but you will need to solder this AD0 connection in, much as you're going to be soldering in the other connections just here. Okay, just let me find my solder. So this is pretty straightforward. Just put the wire through the board. It's just going to hold itself there by gravity. Solder the top side of the board. There we go. Clip it off. Do the next connection now. You'll notice that I'm using a battery powered soldering iron. That's not any particular recommendation. They only tend to work for the smallest of joints, but it's very convenient when you're making a video to use something which is so portable. So I've soldered those two, the last two connections there. You'll see that the wires are, you might just be able to see those, are sticking out of this side of the board. Because the Raspberry Pi is going to be mounted here, these need to be cut very, very close to the board before you solder them on the other side, just so that when the solder that you have on these joints, when it comes through, it won't touch the bottom of the Raspberry Pi. So I'm just going to solder through those last two joints. Okay. Right. Next thing I'm going to show you is how to prepare the Raspberry Pi. So what we've got here is a Raspberry Pi Zero. This is the Pimoroni LiPo shim, and this is a 2x6 header. So first thing to do is the LiPo shim comes with one of these little pieces of rubber mount. That makes it easier to provides a bit of security on the board. That just fits to the Pi about there. Okay, very good. So the next thing is this 2x6 piece of header strip here. That again is mounted the wrong way around. So the long pins of these here go through the top of the Raspberry Pi like this, so that they stick through the end of the Raspberry Pi and leave the short pins and the plastic on the top end of the Raspberry Pi. Okay. The LiPo shim fits on top of the stack here. Okay. So what you do when you're soldering these, I'll normally solder in the LiPo stack in first. So solder in the LiPo stack, all 12 connections there, and then solder the bottom of the bottom of the Raspberry Pi. Try to use as little solder as you can for these connections at the bottom of the Raspberry Pi, because the solder which is running up the pins will make it harder to mount on the board eventually, because these holes will be quite tight if there's lots of solder on these pins. So that's how you prepare the Raspberry Pi stack. You'll also see that before I soldered in the shim, I put these three flying leads in, these three green flying leads that you'll see here. You'll see where those go in a bit, but they don't need to be as long as this, they need to be half the length. But it's easier to solder these in first, because you want them to be really, the solder connections to be really tight at the bottom, so that they don't short against the Raspberry Pi. Okay, so just let me show you how the I'll just show you how to mount the switch and the LED. So you've got this, you've got your board here, and here is a case that I prepared earlier. Notice that I've mounted the switch already. You may need to splay or lift the pins of the switch slightly so that they fit onto the pins on the board. So what you do, you just put the circuit board on in the case. And it's actually easier to make sure it's in exactly the right place if you actually screw it in. Oops. So you can see these two pieces of these two legs of the switch are connected. For the LED is pretty much the same. Make sure you've got the anode and the cathode the right way round. The cathode of the LED is the short lead, I think, but the marks on the board, so that's positive. You've got the positive and negative markings on the board for the anode and cathode of the LED. And you might need to splay them slightly. Okay, looks alright. So just solder those in. So you won't be able to see very much of this because of the way the angle of the camera is. Well, I've successfully managed to fuse the two of those, so I'll sort that out later. Anyway, I've made a mess of that, but you get the general idea as to how to mount the switch and the LED. Let's try and correct that now. There you go, that's much better. Okay. The reason why we mount a solder and mount it this way is because in case you ever need to take this out, it all comes out together in one piece and all go in together in one piece. Okay, the last thing to look at is the mounting the Raspberry Pi onto the board. So here's Raspberry Pi that I prepared before. See the three flying leads. I've soldered all the connections top and bottom, and all that needs to be done is to push the Raspberry Pi into the board, when you're doing this, make sure it's reasonably even and that the Raspberry Pi is not touching the IMU board here, just the IMU board just here. Okay, then you can just connect up the 3 flying leads. They are in order, so 1, 2, 3, 1, 2, 3. And all that remains before we finish the board is just to solder the bottom of the Raspberry Pi here and the 3 flying leads. And that's it. Very good. Just a little postscript regarding something I forgot to mention. Sometimes when you're soldering in the flying lead to connect to the battery terminal, that fits to the top of the LiPo shim just here. Now, the LiPo shim is set up so that its negative terminal is this side and the positive terminal is on this side. But some of the leads that you buy that fit into that socket have the leads, the red and the black leads the other way around, so that the black lead here is going to the positive terminal and the red lead is going to the negative terminal, so defying all convention. It doesn't matter, but just something to watch and save confusion, so that when you are soldering this onto the battery pack, so here's the prepared battery pack, for this type of lead with the red and black this way around, you need to solder black lead to the positive terminal. Notice that I put little pluses and minuses on the battery terminals to save me getting confused. So the black lead goes to the positive terminal and the red lead goes to the negative terminal. There we go.